This video is to fill out our notes and to show how we're going to be doing our rotations because it is different than some of the other material out there. It works either way, but I think we have a more direct way to get it done. And so first, let's just fill out our notes. Find this page in your notes where it says rotations about the origin. We're not going to do a lot with this section, honestly, but we're going to fill in a few things right here. So first, just to define, a turn around a fixed point called the center of rotation. And oftentimes we do just say center instead of center of rotation. The figure rotates at a specific angle. For us, it will be multiples of 90, but it could be any angle if we were using a computer to help us or something. And direction. More about that in just a minute. Though the figure can rotate around any fixed point, the most common is the origin, but we're going to practice both ways. In fact, I'm going to show you a method that works for either. So because of that, we're not going to worry about specific rules. Cross that out and cross these out. We're not going to look at specific rules that only work for the origin if we're going to be able to use any point. So instead, I'm going to make use of the space over here and write a couple thoughts about direction. My first thought is if it's clockwise, which sometimes you see abbreviated CW. A clockwise rotation, CW clockwise, is going to be negative. So if you see negative 90 degrees, that's another way to say clockwise 90 degrees. Counterclockwise then, CCW, counterclockwise, is positive. And so that's the direction we go by default. Now, most of the things in this packet actually say clockwise or counterclockwise, but a lot of times you see the positive or negative used in math as a quick way to say that. All right, I skipped a few pages in my packet, so go ahead and find this page that says rotations about other fixed points up at the top. We are going to use this to figure out how to do our rotations. As it says over here, a figure can be rotated around any fixed point. I'm going to underline any. In the example to the right, triangle ABC is rotated 90 degrees counterclockwise. That would be positive 90 if we were writing it that way, about P2, 3. This means point P with coordinates 2, 3. So they started with this triangle without the primes. They rotated it positive 90, also known as 90 counterclockwise, but instead of using the origin as the center, they used this point. And so what that means to me in this picture, if I connected from A to P, and then I connected A prime to P, and I measured that angle, it would be 90 degrees. And starting at A and moving to A prime, it would be counterclockwise or positive. The same would be true if I connected C to P to C prime, 90 degree angle, or B to P to B prime. So sometimes you see that as our method of creating our rotated image, actually drawing in those angles and looking at the degree measures. But I have a little different way to do it. So I'm going to come down here. I'm not going to worry about their method. I'm going to use my method. So first, let me just go ahead. I'm going to pause for a second and get my triangle ready to graph. All right, so here you see that I have graphed the original triangle that they gave me up here. The other thing I need to graph is the point P, which is at 1, 2. And yes, I label that as well, so I remember that that's the center, not one of the points of the triangle or something like that. In this case, we are also doing a 90-degree counterclockwise, so a positive 90 rotation. Here's how I do it. I make use of something called patty paper. I put the patty paper down on my diagram. I highlight the 3 points and label. If you don't label, you're going to get mixed up at some point. I go ahead and put a dot there. And here's the other thing I do. I always use the y-axis for this. I make an arrow that points straight up. In other words, where is north? Because now, when I put my pen down on the center, not on the origin, on P, and I rotate the patty paper, I can see when that arrow is facing exact left. Now notice it's not necessarily lined up with the axis, but it's lined up with one of the markings there. And if you needed to take it back and make it a little bit longer to see that better, you can do that. Now when I move it, I can see it lined up on there very well. I can now see where X prime is going to go. I can see where Y prime is going to go, and I can see where Z prime is going to go. And the only part that's tricky at all is keeping the patty paper kind of in place while I put those in the right place. I have a hint for that though. Instead of doing that, let's see, there's the origin when I'm reading the points. If I look at coordinates, 1, 2, 3, 4, 1, 2, 3, 4, 5. So -4, +5. I can write that over here. And if I look at Y prime, I have -2, 1, 2, 3, 4, 5, 6, 7, 8, 9. And Z prime at 0, 1, 2, 3, 4, 5, 6, 7. Then I can remove the paper and simply graph those points. Now that I graphed my new points, we can see a couple things going on here. We can see that this triangle is the same shape, same size as that one. It just rotated around, took that motion around. If I made a connection from, let's say, X down to P, I'm doing this in pencil so I don't ruin my paper. I hope we can see it. If I connected there and I connected X prime to P, now I see that 90-degree angle, that 90-degree rotation that happened. I could also connect Y to P to Y prime and get a right angle, or Z to P to Z prime and get a right angle. That's the way we do rotations using patty paper.